Hey guys, Mr. King here. Today we are going to be talking about chemical energy, and chemical energy is a form of potential energy. In other words, it is stored energy. You find chemical energy in food. The way we release the chemical energy from food, it's got stored up energy inside it, is we eat it. And once we eat it, it breaks it down in our body. We get the protein and the carbohydrates and the fat from it, and that allows our body to function. Another form of chemical energy is also gasoline. Okay, inside the chemicals that make up gasoline, there is a tremendous amount of stored energy. So once again, chemical energy is a type of potential energy. And if you release that energy in gasoline, you're able to have a large explosion or a large fire. So we're going to talk about chemical energy and where it comes from and how it kind of bonds together to form some different things. So chemical reactions transform energy. So they go from one form of energy to another. Remember, in any chemical reaction, even though energy changes form, there is no energy created or destroyed. It just looks a little different or takes a different form. So in a chemical reaction, compounds are broken down or new compounds are formed. And we've talked about in a chemical change, the sign of a chemical change was you get a new substance, versus when we talked about a physical change, you get a change in size, shape, color, mass, state of matter. All those are physical changes. A chemical change, if you remember, would be like burning a piece of wood, where instead of being wood, it becomes smoke and ash. So you get something totally new. Or maybe the Statue of Liberty getting a patina on it from that copper reacting with oxygen. So the compounds get broken down. So like if we wanted to break down water, H2O, you separate the hydrogen and oxygen. And in order to do that, it requires some energy. Energy in chemical bonds is a form of potential energy called chemical energy. And in every chemical reaction, energy transformations occur. In other words, they take a different form. And so if you expose water to electricity, that is a chemical reaction because you are able to split the hydrogen and oxygen atoms apart from each other, and that makes it no longer water. And so that is an example of a chemical reaction that shows you a chemical change. If you run electricity through water, you no longer have water. You have a different substance because you've broken down that compound and divided those atoms. So in order to break the bonds between the atoms that are bonded together, and remember that's what a compound is, where you have two or more elements bonded together, you have to add energy. And you can add energy in a variety of ways, whether you're talking about adding heat or light in some cases. When we talked about breaking down water, we talked about adding electricity. All of those things require energy to be added, and the bonds are pretty strong. Water is bonded together pretty strongly, and so in order to break that, it takes a pretty substantial amount of energy to break those bonds. Now, on the other hand, to form a chemical bond, energy gets released when you form those bonds because they have joined together, and that allows them to release their energy. So you can kind of see the difference here. We're talking about breaking bonds and forming bonds. In order to break a bond, you have to add energy. And when you form a bond, energy is released or given off. So there's two very, very different types of chemical reactions that can occur when things kind of bond together. Our first type of chemical reaction is called an endothermic reaction. And this is a chemical reaction that absorbs energy, so it takes it in. An exothermic reaction is a chemical reaction that releases energy. And we'll be doing some experiments in class where you guys will be seeing these types of reactions when you mix some different chemicals. A lot of the times when you guys think of science class, you think of pouring things together and watching them fizz up or maybe watch them change color. These are those types of reactions. In order for things to fizz up or maybe to boil over, energy has to either be released or absorbed in order for that change to happen. And these are the types of reactions that we're going to be using. So endothermic is pretty easy because the energy goes into it. It absorbs it. So the energy goes in, and endothermic kind of sound like that. Exothermic reaction, the easy way to remember this one, is it releases energy or the energy exits. Exothermic and exit. So you've got a couple little tricks to help you remember those. Now when we do some labs with these in class, you'll see there is a very obvious either exit of energy or an addition of energy. And some of the classic ones that you guys might know, baking soda and vinegar. That's a really classic chemical reaction where you can see things fizz up. We're going to do some other reactions with some different chemicals where you mix them together and they really heat up. Okay, so they're able to absorb that energy and absorb that heat. So we'll be talking about these a little bit more in class. Now, how fast these things happen, it depends on some things. Chemical reactions occur at different rates. A catalyst is a substance that you can add to a chemical reaction that changes the rate of it without its own structure being changed. So if you add a chemical to a chemical reaction that makes it go faster or slower, that is a catalyst. Now, the key to this is its own structure doesn't get changed. In other words, it doesn't break down. It's still the same thing, but it allows the chemical reaction to proceed a little bit quicker or maybe a little bit slower. And this can come in handy depending on whether you're doing an experiment or if you're trying to melt ice, for example, outside. Sometimes you want to melt the ice really quickly, and so you can add a catalyst to help with that. You guys have all sprinkled salt or driveway pellets on an icy area, maybe your steps, or maybe you've seen your parents do it. That's a chemical reaction. Those little pellets react with the moisture on the ice and they absorb that heat in that reaction. So that's an endothermic reaction because the heat goes in and it melts away the ice. And that allows that substance to go through a chemical change in order to melt your ice so you can be safe. And that's a really good one that we use often, and that's a lot of the times in Michigan why we have our salt trucks out, is the salt or the sodium chloride reacts with the ice in that way when you mix it with moisture. And so that creates a little bit of heat, which allows you to melt through the ice. So here's a couple chemical reactions, and this is really broken down pretty simple. You can see in the first example, A and B, this would just be two atoms, and that would be two atoms joining together to form a compound. The other one, the second one, you have two letters, the A and B, that are already joined together, and you break them apart. And now you can see they are no longer joined by a chemical bond. In example number 3, A and B were bonded together. They went through a chemical reaction. Now A and C are bonded together, and B is the additional atom. And in the final example, A and B were bonded, and C and D were bonded together. After the chemical reaction, they switched who they were bonded with. And that reaction can proceed because of some sort of catalyst or some sort of interaction between the chemicals where we are forming a new substance. Remember, we talk about a chemical reaction or a chemical change. You always get a new substance, and you can look at these and see that they are a new substance. Even though the letters are the same on both sides of the equation, before the arrow and after the arrow, they have bonded in a different way. And so that's what makes this a chemical reaction. Alright guys, like I said, we're going to do some more labs with this, get you a little hands-on time with these and show you what these look like in real life. Make sure you fill in the WSQ, write some good questions, don't forget the quiz on the back. You guys all have a great night, and I will see you tomorrow.